Alright, so the last time, which was last week, we started off with complex numbers. I introduced you to the concept of the square root of -1. So what did we do when we had the square root of -1? We used a substitution. We can use the symbol I or J. Then what did we do? We worked out a quadratic equation. We solved a quadratic equation with unreal roots. Okay, and that's where we introduced the square root of -1, which is I or J. Then, now we're going to continue with converting from one form to another. Then we're going to be adding, subtracting, multiplying, dividing, exponent laws, all dealing with complex numbers. Now, so we started off with this form here. When we simplified our answer, okay, when we were solving for x, I told you need to separate it. You need to separate it into two parts. So here we have the real part, and then we have the imaginary parts. Okay, so if I have z is equal to a plus j times b, or a plus, it doesn't make a difference whether it's j times b or b times j, it's multiplication. Right, so now we know that this here is the real part, and the part with j is called the imaginary part. Or you can say the unreal part. So now we can represent this just like how we represent coordinates on the xy axis, Cartesian plane. We can represent this now on something called the Argand diagram. So here, if you look at this, it's similar to an xy axis, but now the x-axis is now called the real axis. So we will plot the real component on the x-axis, and the y-axis is now the imaginary component, or the unreal part. Okay, so let's take an example, like let's say if we have z is equal to 3 plus 4j. Okay, so now my real part here is 3. So if I go 0, 1, 2, 3, so here is my 3. And the unreal part of this here is 4. Okay, it's actually 4 times j. So if I go 1, 2, 3, 4, so here is my 4 here. So now this point 3, 4, it's like marking off a coordinate. X is equal to 3, y is equal to 4. So here is your point here. So now what do? You take your ruler and you draw a line straight from there to this point with an arrow, because this is going to have magnitude and direction. Okay, because you could be in the first quadrant. This is an example of a complex number in the first quadrant. What happens if I had -3? If I had maybe z is equal to -3 plus 4j. So instead of the real part being +3, now we have a -3. So we have a -3 here, and it's the same 4. So then I take my ruler and draw a line. Right, so now here this is z is equal to 3 plus 4 times j. This complex number here is z is equal to -3 plus 4j. Alright, so now what do you notice now? If I have to drop a perpendicular line perpendicular to the x-axis, let's take this one here. What shape do you notice appears? a triangle. So but if it's, remember I'm saying perpendicular to the x-axis. Perpendicular means it will intersect at an angle of 90 degrees. So if it intersects at an angle of 90 degrees, then this is now a right angle triangle. Right, so from the positive x-axis to this point here, there's actually an angle. Okay, and also from here to there, from the origin to this quadrant 3, 4, which part of the right angle triangle is that column? Now remember, the distance from here to here is 3, from here to there is 4. But now this is the side that's opposite 90 degrees. What do you call that side? It's the hypotenuse. Okay. So in complex numbers, we're going to refer to the hypotenuse as r. Okay. Now, if I want to work out the value of r, okay, I know that the distance from here to here is 3 units. So remember, if I go from here to here, that is 3 units. From the bottom there, this is 4 units. So what's missing is the hypotenuse. How will I work it out? What theorem can I use to work out that side? I can use Pythagoras. So if I use the theorem of Pythagoras, the theorem of Pythagoras states that the square of the hypotenuse, which is r squared, is equal to the sum of the squares of the other two sides. So, in general, remember, this here is your a value and this is your b value. Right, so r squared is equal to a squared plus b squared. Okay, in general, what is your a, what is your b? For this example, your a value is 3, you can see it's 3 here, and your b value is 4. So therefore, if r squared is equal to a squared plus b squared, so then if I want to find the value of r, I will find the square root of both sides. So r is equal to the square root of a squared plus b squared. So in this case, I have z is equal to 3 plus 4j. So your r is going to equal to the square root of 3 squared plus 4 squared. So that's going to be 3 squared, which is 9, 4 squared is 16. So 9 plus 16 will give me 25. And then the square root of 25 is 5. Now, there is a specific term for r. Okay, in here r is called the modulus. Right, so if they ask you to find the modulus, you remember that it's actually the hypotenuse of your right angle triangle. Right, it's just that there's different terminologies here that you need to get used to. Right, but if you remember the picture, then you will not forget. It's just a simple right angle triangle where we're using the theorem of Pythagoras. Now, we found r. What about this angle theta? How do we find that angle? So let's have a look at this triangle that we have here. So here is your right angle triangle. That's theta, we know. Now, we have all the sides. We have this, we have 3, we have 4, and now we just found the side, the hypotenuse, which is 5. But now, let's assume that we did not find the hypotenuse. So let's use the given information. From here to here, we know is 3 units. From there to there is 4 units. Alright. Now, why am I not using the r value that we just found? Let's assume in the exam you made a mistake. And instead of 5, maybe you went and made a mistake here and you wrote 6 or something. So then you will take that same wrong answer and use it to find the angle, which will still be wrong. So therefore, go back to the information that was given to you, which is always your A and your B value. It's always these two values here. In this case, it's 3. It won't always be 3, but basically, you have what's this value 3? Which side is it in relation to that angle theta? It's adjacent. So this here is adjacent. And what about this side here? This is opposite. And we know that this is the hypotenuse. So now, if I want to find the angle, this is a right angle triangle, so therefore I can use ca, to. Which one am I going to use here? SOCA or TOA? So now, I have the adjacent side and the opposite side. So basically OA, that's the two letters we look at. We look at O and A. Is this OA? No, this is OH. Is this OA? No, that is AH. But there's OA here. So therefore, I will use tan. So now I'm going to go tan of theta is equal to opposites over adjacent. So now tan of theta is equal to opposite, which is 4, and adjacent is 3. So now I can work out theta. So what I will do is I will go inverse tan of both sides. So inverse tan of tan theta, basically it's cancelling each other out, which is just theta. I'm finding the inverse of both sides. So inverse tan 4 over 3. That means on the calculator you're going to go shift for second function tan. Make sure your calculator is in degrees here. So that's 4 over 3. What do we get? 53, 13 degrees. Okay, so now that is your angle, and this, there's a specific term for it, just like your hypotenuse is not called the hypotenuse here, it's called the modulus, and your angle theta is called the argument. So you can be asked to find the argument, you must know. Simply you're finding your angle theta in your right angle triangle. If you're asked to find the modulus, basically you're finding the hypotenuse of your right angle triangle. Now, this information that we just found, we found your angle theta, your argument is 53,13, and your R value is 5. So now, this can be represented. It's called polar form. Okay. So now we have Z is equal to A plus JB. So remember, Z was equal to your 3 plus 4J. And now this was your rectangular form. And now we converted it to polar form. There's two ways to write down your polar form. Okay. You got R and you have this line over here. It looks like a right angle with your theta. So you got your R. What was the R that I just found now? It was 5. And your angle theta was 53,13 degrees. Or instead of using this symbol here, this line to represent, you see the letter CIS. Sometimes if you see that in your book, you must just know that it represents this line here where your angle sits on top of. Can you see that? So there's two ways. Now, so remember that this is called polar form. Okay, now, before we move on to the next step, before we convert back to rectangular, this can be verified on your calculator. So take out your calculator. All calculators can do this here. So what you're going to do is you're going to press shift, and then you are going to press the plus button. Can you see the plus button there? Now what appears on your calculator is POL there, am I right? With an open brackets. Now, the first number that you're going to put in, what are we doing now? We're going to use our calculator to verify our answer. Alright, we're going to check now. So the first number that you're going to input is 3, so you press 3. So basically you got POL, you're going to press 3. Now you need to find the comma. To get the comma on the calculator is shift, and the comma is in yellow there. I think it's above the number 8, somewhere around there. Check the comma. Comma. Shift and see there. What number is the comma? Above 9. Okay, you got the comma? Now you're going to put in 4. Press your 4. Close your brackets. Press equals to now. What appears there? The answer appears. It gives you r is equal to 5. Move your arrow more to the right, and then you can see theta is equal to 53,13. So you got your calculator to make sure that your answer is correct. Okay. Now, what you have to show working, obviously, in maths and other subjects like industrial electronics and electrotechniques. Then they don't have to go and show everything there. They can just use your calculator. Alright, so we got that sorted out. Now, let's go back. Let's go back to our real and imaginary axis. Alright, so now, how do we convert back to rectangular form if you're given something in polar form? So now, here is my, I'm just taking an example, any number in general, so let's just call this A. You got your A value here, which was 5, can be 6 or whatever, so there's your A. We know going up is B, and then what do we have here? Is R. Okay, so remember now, since we found this, we can go back to our diagram. Sorry, I forgot to do that. So I can write down my R is equal to 5 and my theta is equal to 53,13 degrees. Whatever information you find, put it on your diagram. Alright, so that was easy. You needed to know your theorem of Pythagoras and SOHCAHTOA TOA. Basically just TOA, that means tan is equal to opposite divided by adjacent. Now, focus your attention on this diagram on the board. So here is your right angle triangle. You have now we have all sides. Can you see that? We have our adjacent, we have opposites, we have hypotenuse. Now, if I write down cos of theta, okay, if I got cos of theta, if I want to find cos of theta, cosine of theta, so cos, CAH, so cos is adjacent divided by hypotenuse. So we know that cos is adjacent divided by hypotenuse. So from this diagram here, what's the adjacent side in terms of A, B, and R? Adjacent means next to the angle, that means your adjacent is A, and hypotenuse is what? R. You're clear with that? Now, if I make A the subject of the formula, so if I go A, what will A equal to?
3.
No, okay, no, I'm talking about as what we in terms of cos theta, A and R. If I want to, from this formula here, if I want to make A the subject of the formula, what must I do? I need to multiply by R on both sides or cross multiply by R. You understand that?
Yes.
I want to make A the subject of the formula. Right, so A will equal to R cos theta. You're clear with that? Right. Now, let's go for sine theta. So if I go sine theta, so SOH, that's so sine is equal to opposite divided by hypotenuse. So what is the opposite side? Opposite angle theta is B. You can see that? So there's my B here. Your hypotenuse is R. So now, if I make B the subject of the formula, if I make B the subject of the formula, what will B equal to? If I cross multiply, it's going to be R sine theta is equal to B. Now, from these two here, so we got B is equal to R sine theta and A is equal to R cos theta. So now, Z is equal to, let's go back to our rectangular form. Remember what was Z equal to in general? In general, I wrote it down that Z was equal to A plus JB. So therefore, I have my A plus J times B. Right. Now, in polar form, we wrote down Z was equal to R theta. Okay. So there is polar form. Z is equal to R theta. Rectangular form, Z is equal to A plus JB. So what did we do? We converted from rectangular form to polar form by using this information A and B to find R and to find theta. Now, let's do the opposites. What happens if you're given R and theta and now you are asked to convert back to rectangular form? So this information R and theta, how is it going to be used? So now there's my A plus JB. Can you see that? So what is A? Remember what we just found here. A can be represented by R cos theta. So there's a chair. So I've got Z is equal to R cos theta plus, what is B? B is R sin theta. So that, oh, don't forget your J there. R sin theta, and that is how we convert from polar form back to rectangular form. Right, so this is the formula. If you want to go and work it out the long way like how I did it, you can, but it's unnecessary. I'm just explaining it to you, showing you the Sot Atoa, but this is how you do it. If you got Z is equal to R theta, then to convert, this is the formula. It's going to be R cos theta plus J R sin theta. Let's do it for the same example that we just worked out. So look here. Z is equal to 5. Let's write that down. Z is equal to, we got our 5. And then we have 53,13 degrees. So this is in polar form. Now, let me just write that down. Converting from polar back to rectangular form. So, if I got Z is equal to R and my 53,13, so now that's going to be, here's the formula, it's going to be R cos theta. So it's going to be 5 cos of 53,13 degrees plus j r sine theta. So plus j open bracket there 5 cos 53 comma 13 degrees, and now you will take out your calculator and you work this out. 5 cos 53 comma 13 degrees, and what do we get there? The calculator must be in degrees because your angle is in degrees here. So what is 5 cos 53 comma 13? It's 3. Plus j times, what is 5? Sorry, this one here is r sine theta. So my mistake there, it is sine. So remember, b is r sine, so that's 5 sine of 53 comma 13. What do we get there? 4. You get 4. Alright, so that's converting from polar back to rectangular. Now let's make sure that this answer is correct. Take out your calculator. Clear your calculator, press shift, and I think it's the negative minus button. The minus button has rectangular when you press it, am I right? So what do you need to input into the calculator? You will input, where is the question? 5 first. Get your comma, you know how to get the comma. Now it's shift, and what's the button? Bracket, open bracket or close bracket? Close. So it's shift, close bracket to get the comma, and now you put in your angle, 53 comma 13. Now you close your bracket, and then you press equals to what appears on your calculator. X is equal to 3 now. The calculator defines it as X. We are calling it A. Remember, don't get confused now. So remember, the calculator defines it as X, which is the real component. We are defining it as A. It means the same thing. And then what else does the calculator show you? Y. The calculator refers to it as Y. We are calling it B. So remember, what is Y? It is B. And you get it. So you know how to check your answer using the calculator. Alright. Let's do a few more. So here, convert the following from rectangular to polar, and then we will also convert back to rectangular. So what do we have? Z is equal to minus 2 plus 3j. Always do a rough sketch. So to check where or which quadrant does minus 2 plus 3j lie. So you know to write down j for your imaginary, a for your real axis. So what do we have here? Minus 2, so there's minus 1, minus 2. So there is minus 2 here. And we have 3, so that will be 1, 2, 3. So you take your ruler and you draw your line there. So there is your right angle triangle. You see that? So let's redraw this. So there is your right angle triangle. And you know the distance from here to here is 2 units. From there to there is 3 units. And the angle that we are measuring from the positive x-axis. So we're going 90, and definitely it's more than 90 degrees. There is your theta. Can you see that? That is your angle theta. Okay, so what are we doing? We first need to find this angle inside. Let's call it alpha. Let's find this angle here first. And then, so if we find this angle, how can we find theta? We know that these two angles add up to what? 180 degrees. Okay. So here, if I go tan of alpha, tan is equal to opposite over adjacent. So there's my opposite, and there's my adjacent. Okay. So I will work out this angle. So then I'm going to go inverse tan of both sides. So alpha is equal to, what is this one here? Inverse tan 3 over 2. We remember now I'm just working on ignoring there's no negative sign I'm putting here. Can you see that? This is 56, comma 30, not 31.
3-1.
Okay, 31. Right, so degrees. So what is this 56, comma 31? It is not the angle measured from the positive x-axis all the way. Okay, it's this angle inside here. This one here. So this one here is 56, comma 31. But this is not the angle that's required. The angle that we want is this angle here. This is the angle measured from the positive x-axis. So you know that this is a straight line, and in a straight line the angles add up to 180 degrees. So if I know that this is 56,31, then I can work theta out by 180 minus that. So therefore theta is going to equal to 180 minus 56,31 degrees, which is equal to 1, 2, 3, comma 6, 1, 6, 9. 1, 2, 3, comma 6, 9 degrees. Alright. Now, in general, let's deal with the first quadrant. So we got the first quadrant, second quadrant, third quadrant, and the fourth quadrant. Okay. So now, this is for dealing with the angle. The modulus is easy. All you do is work out the theorem of Pythagoras and you get your answer. You don't have to worry about which quadrant you are in, because you're going to square A and you're going to square B. Whether it's negative, it's still going to be, the result will be positive. This is the part where most people make a mistake with, is finding the angle. So in the first quadrant, we know that theta is equal to inverse tan B over A. Now that we encountered a problem in the second quadrant, theta was equal to 180 minus inverse tan B over A. So remember your class diagram. What happens in the third quadrant? What do we use in the third quadrant? 180 plus inverse tan B over A. And then in the fourth quadrant, what will we use in the fourth quadrant? 360 minus inverse tan B over A. Remember your basic class diagram, you have to have knowledge on, not on everything in trigonometry, but the cast diagram, just to remember how to get your angles in each quadrant. So remember this one is theta, and then we got 180 minus 180 plus and 360 minus that. So that was your theta, which is, remember, you are in complex numbers, so you must write down argument in brackets there. And then the modulus. The modulus R, that's simple. It's equal to the square root of a squared plus b squared. And my a and b here are minus 2 and 3. So that will be the square root of minus 2 squared plus 3 squared. So that's the square root of 4 plus 9, which is the square root of 13. Round that off to 3 decimal places. 3,61. Right, so that was easy, modulus. Okay, straightforward. Substitute your values into the theorem of Pythagoras formula and get your answer. This you need to be careful with. Do not, you can see that I did not substitute any negatives into the calculator. I'm simply drawing my right angle triangle, finding this angle, and using 180 minus if I'm in the second quadrant. If I'm in the third quadrant, 180 plus, which is the next one. Alright, let's deal with the next one. Okay, before, sorry. So now, Z is equal to R theta. So you need to write down your answer. The question was convert to polar form. Your final answer must be in polar form, which was 3,61 for R, and your theta was 123,69. Give me the calculator. So remember, you need to verify this on the calculator. Check if your answer is correct. So you know what to do. You're going to go shift plus button to get polar. Right, so it's a shift plus button to get your polar form. And now, what you need to input is -2. So I got my -2, there's my -2 here. And then to get the comma is shift close bracket. And then the next value here is 3, so I'll input 3. And then close my brackets. So there's my close bracket now. And I press equals to. So you can see what the calculator gives you. The calculator will give you 3,61. Move to the right 123,69 degrees. Easy. Okay. You cannot go wrong because the calculator is there to make sure that your answer is correct. Just that you need to be careful with the angle when you're working it out. Right, let's deal with the next one then. So B Z is equal to 4 minus J. Let me give you 1 minute or 2 minutes. Let's work it out. Alright, the next one here, Z is equal to 4 minus J. So, first thing is to determine which quadrant you are in. So you do your Argand diagram, easy on the side here. So that's your J, that's your A value. So we know that the real component there is positive 4. And the unreal part here is minus 1. So there's it here, 4, -1. Take your ruler, draw your vector which has magnitude and direction. And now, here is your right angle triangle. You can see that. So now your angle is going 90, 180, 270, and in between 270 and 360 degrees because you are in the fourth quadrant. If you are in the fourth quadrant, you are in between 270 and 360 degrees. That will be your theta value. We work that out, and we need to work out R. Okay. So, in the fourth quadrant, theta is going to equal to 360 degrees minus whatever angle you work out inside that right angle triangle. Can you see that? So that right angle triangle is always opposite over adjacent. It's always inverse tan. You're clear with that? That's why. Why are we using inverse tan? Because we are using the given information. We're not using the hypotenuse here, but you can if you want to. So it's going to be 360 minus inverse tan, only positive B positive A because we are referring to distances, the length of the side here. We are ignoring the signs. We know that we are in the fourth quadrant. Right, so we ignore the signs. Just like how I ignored the signs here, you can see it was a -2. But when we are talking about the distance, it's actually 2 units. It's a sign. So now, so that's going to be 360 minus inverse tan B over A. So that's going to be 1 over 4. Okay, so although it's -1, you do not put -1, you will put a positive 1. This 360 will take care of everything else. So 360 minus, give me the answer there quickly. Too long. Time is running out. How long does it take to type this out? 360 minus inverse tan, 1 over 4. What do we get? What's it? 345, comma? 96. Everyone gets the same answer. Does it make sense? Yes, it's in between 270 and 360 degrees. Right, so that is your theta. Remember, don't forget to write down argument in brackets there. So that's argument. And now we're going to work out the modulus. R is equal to the square root of these two values here. Here it doesn't matter whether you put down the positive or the negative. Because if it's a negative, you're still squaring it. It will result in a positive. So that's going to be the square root of 16 plus 1, which is 17. Square root of 17. 4,12. Alright. Now that you got the hang of this, yeah, it's easy. You just need to make sure that you are in the correct quadrants for the angle. So therefore, Z is equal to R theta, that's polar form. Your R was 4,12 and theta was 345,96 degrees. Let's do one more there. And then we move on. Okay, so before we move on to the next one, let's verify what do we get on the calculator. So I'm going to convert this. So I'm going to go shift plus sign, which polar form comes up. I got my 4, shift close bracket for my comma, and then I put in my -1 close bracket. So the calculator is giving me 4,123. Okay, that is fine. That's what the calculator gives me there. And then theta is equal to minus 14,0362. So theta is equal to minus 14,0362. So the calculator gives us a negative angle. So let's write this down here. So the calculator, theta is equal to minus 14,0364, and it carries on and on there. Now, the instruction in the maths paper is theta may only be positive. So the calculator is giving you a negative value. How do you convert a negative angle to a positive angle? We've done that in N3. Okay, to convert this to a positive, any negative angle to a positive angle, all you're going to do is add 360 degrees to it. Okay. to make sure that your answer is correct. So we're going minus 14, comma 03624 plus 360 degrees, and then you get your 345,96. So if your calculator gives you a negative, write it down and then add 360, you get your answer one time. Right, so remember that. Add 360, let's deal with the last one. So we got minus root 2 minus square root 3j. So first thing is, determine which quadrant you are in. Do a rough sketch. So the a value, the real value is negative. So on the x-axis, it's called the real axis now. That is your negative root 2. Somewhere around here. Let's put it as negative root 2. Okay. The j value there, the unreal value, is also negative. So you're going down now. So that will be negative root 3. So there is the coordinates. We are in the third quadrant. Okay, it's like x negative, y negative. Real is negative, imaginary also negative. We are in the third quadrant. So the angle that we are expecting is in between 180 and 270 degrees. So third quadrant, theta is equal to 180 plus. There's a shade. If you ever forgot it, it's a cast diagram. Third quadrant, we use 180 plus. So that's 180 plus inverse 10, and here we do not substitute any negatives. Okay, I showed you an example. There's no need to put any negative there, but be careful, don't go and substitute the other way around now. It's always b over a, not a over b. It's always b over a. So the coefficient of j will always be the numerator, and the real part will always be the denominator. You do not need to put in the negatives. Give me the answer there quickly. 230 or 213? 230. 77. Read out 5 decimal places for me then.
76847.
76847. Okay, next time. 1, 2, 3, 4, 5. So therefore this is 230, 768 degrees. So therefore Z is equal to, oh, I forgot to find R here. Let's find our R. That's your argument. So R is equal to the square root of a squared plus b squared, so that's minus root 2 squared plus minus root 3 squared. So the square root of 2 squared is just 2. The square root of 3 squared is just 3. And then we got the square root of 5, which is
2,236.
2,236. Okay. Now that is converting from rectangular to polar. To convert, remember, you already have the answers. You can always go back and convert now from polar back to rectangle. Okay, let's take this one. Let's take one example. That's the easiest thing to do, is to convert from polar back to rectangular. So if I want to take this one here, 4, 1, 2, and your angle is 3, 4, 5, 9, 6, and if I want to convert it back without, obviously not using the calculator now, showing working. So remember, Z is equal to R cos theta plus J R sin theta. That is the formula. You don't have to go and do it the long way like how I was doing it before. The formula is always going to be R cos theta, R sin theta. So you will write down the formula and then substitute R. What is the R value here? For this one here, your R is 4, 1, 2. Cos of theta, which is 3, 4, 5, 9, 6, plus J R sin theta, so that's going to be 4, 1, 2 sine of 3, 4, 5, 9, 6 degrees. And then you use your calculator, and then you get back to, I'm using this example, you'll get back to 4 and minus 1. You'll get it? This is the easy one. Okay, just substitute straight into that formula. Whether your angle is positive or negative, you substitute it as it is. So even if I had maybe minus 50 or minus 60, you substitute straight that negative. So the calculator will work it out for you. Okay, so that was converting from rectangular to polar, and then from polar back to rectangular. You're straight into that formula that you substitute. Now, let's go back to rectangular form. We must be able to add, subtract, multiply, and divide all in rectangular form. Right, so adding complex numbers in rectangular form is like adding variables, like when you have x and y. So if I have something like 4 minus 2x plus 3 3 plus 6x, how do I do this? All I do is add up like terms. Okay, we've been doing this from primary school, just that now you don't have x, you have j here. So if I add this up, I will add up my constants. 4 plus 3 will be 7, and then minus 2x plus 6x will be positive 4x. You cannot add 7 and 4x. Okay, you can only add like terms. You add the variables with the variables, the constants with the constants. Now, let's take these are complex numbers here. So, I gave you 3 complex numbers. I'm calling them Z1, Z2, and Z3. First one, Z2 plus Z1. So what is Z2? Z2 is represented by minus 3 plus 7 times J. Right. Plus Z1. What is Z1? Z1 is 4 minus 2J. All I do is add up my like terms. So I've got minus 3 plus 4 there, which is a positive 1. And then I have 7J minus 2J, which is positive 5J. So that is 1 plus 5J, and that is all. That is how you add these complex numbers in rectangular form. I want you to do the next one before I do it on the board. Next one, Z3 minus Z2. So what is Z3? Z3 is 5 minus J minus Z2. What is Z2? Straight away, before I even wrote down Z2, notice, what am I doing here? I'm introducing brackets. You should know, you've been doing maths for how many years now? As soon as you put a negative sign, and there's more than one term, you're going to subtract. You must introduce brackets. Right, so Z2 is minus 3 plus 7j. Now remove the brackets by multiplication. So we have 5 minus j, negative times negative is a positive 3, and negative times positive is negative 7j. So therefore, this is now equal to 5 plus 3, which is 8, minus 1 minus 7 is minus 8j. Alright, so be careful with the negative sign. Always introduce brackets. Now, that was adding and subtracting. Let's deal with multiplication. Z1 times Z2. So we got Z1 times Z2. Z1 is 4 minus 2j, and Z2 is minus 3 plus 7j. Multiply this out, just like how you multiply when you're multiplying with x or any other variable. Let me give you 1 minute, it only takes a few seconds. Multiply that out. Alright, so multiplication, we're going 4 times minus 3, which is minus 12. 4 times 7j, which is going to be 28j. And then minus 2j times minus 3 will be a positive 6j. And then minus 2j times a positive 7j will be minus 14. And remember, there's a j times a j. It's like x times x. What's j times j? J squared. Okay, so now it's the first time we are coming across a power higher than just 1, j to the power 1. Okay, so now we have j squared. Okay, so now let's simplify further. So we got minus 12, then we got 28 plus 6, which is going to be 34. J minus 14 multiplied by j squared. Now, let's go back to the definition of j. Remember that j was equal to, what was j equal to? The square root of negative 1. Okay, so if our answer has j there, it's fine because j is our substitution. But if the answer has j squared, j to the power 4 or j to the power 1000, you need to work it out. And your answer must be in terms of j. So, exponent law. Right, so now if I have to square j, that means I'm squaring the left hand side of that equation because this is what I want. I want to know what is the value of j squared. So if I square j on the left, that means I have to square the square root of negative 1 on the right. Whatever I do on the left hand side, I do on the right hand side. So therefore, j squared is equal to what will I get here now? Negative 1. Because when you square the square root, what happens? From your exponent laws, the 2.5 will give you, basically you can say the square root will be out from there. Right. So therefore, j squared is negative 1. So from now onwards, everywhere that you see j squared, you cannot leave it as j squared. You must substitute negative 1. So that's why I'm introducing a bracket now, and in place, remember this is minus 14 multiplied by j squared. So it's multiplied by minus 1. Can you see that? So therefore it's going to be minus 12 plus 34j. Negative times a negative is positive 14. So now 14 minus 12 is 2 plus 34j. Alright, next one, z3 times z1. What is my z3? Z3 is 5 minus j, z1 is 4 minus 2j. Do that quickly. Right, so let's deal with this here. 5 minus j times 4 minus 2j. Multiplication, so 5 times 4, you get 20. 5 times minus 2j is minus 10j. Minus j times 4 is minus 4j. And minus j times minus 2j is going to give me a positive 2j squared. So now I got 20 minus 10 minus 4 is minus 14j plus 2 multiplied by j squared, and we know that j squared is minus 1. So now that's going to be 20 minus 14j, a positive 2 times a negative 1 will give me a negative 2. 20 minus 2 will give me 18 minus 14j. That is multiplication. Now, division. Alright, so before we deal with the division problem, there's another concept that you need to learn. It's called the conjugates. Okay, so now we need to just understand how to write down the conjugate, and then we will be able to do the division. Without knowing the conjugate, you cannot do division. So conjugate means, now, let's say if I have, let's say z is your complex number. If I want to write down conjugate, I'll put z with a line above it. Now, what does it mean? So let's say if I got a plus or minus b times j. Okay, that is the original complex number. Then the conjugates will equal to a minus plus b times j. So this covers everything. What does that mean? Let's take an example. If I got z is equal to 2 plus 3j, and if I ask you to write down the conjugate here, z with the line above, what is the conjugate of 2 plus 3j? That means you look at the sign. If it was a plus, the sign changes to minus. So that the conjugate of 2 plus 3j is 2 minus 3j. Okay. What happens if I give you z is equal to minus 6 minus 4j? Okay. What is the conjugate of minus 6 minus 4j? What changes? Does the sign of a change? No. Only the sign of j, the coefficient of j, of the sign of j will change. Nothing else. That's the only thing that changes, is the coefficient, or basically the sign for j. Right, so the conjugate of minus 6 minus 4j is minus 6 plus 4j. Okay. So now, let's say one more now. Z is equal to 1 plus j, and the conjugate of 1 plus j is going to equal to 1 minus j. Can you see that? So z is equal to 1 plus j, the conjugate will be 1 minus j. Now, let's take these two here. Let's focus our attention on the conjugate of 1 plus j is 1 minus j. So what happens if I go z times the conjugate of z? So this is a complex number, and the conjugate of the complex number. Now what am I saying? I'm saying take the same complex number and multiply it by its conjugate, which we know how to do, multiplication. Let's have a look at the results. What appears here? So z is equal to 1 plus j, and the conjugate of z is 1 minus j. Multiplied out, we got 1 times 1, which is 1. 1 times minus j is minus j. J times 1 is going to be a positive j. And then j times minus j is going to equal to minus j squared. So, now, what do you notice here? It's out, 0. Minus j plus j is 0. So I'm left with 1 minus j squared. But what is j squared? Minus 1. So now 1 minus minus will give me plus, and 1 plus 1 is 2. So the lesson to be learned here is that when you take a complex number and multiply it by its conjugate, the result is not a complex number, it's a real number. Can you see that? Now, why do we need to know this? Is because when we are doing division, so let's say if I got 4 plus 2j divided by 3. Okay, let me not put 3 there, let's put it as 2. This is okay, we can divide this here. We can take the complex number and divide it by the real number, because this is, remember we did this when we were solving quadratics equations here. So that will be 4 divided by 2 plus 2j divided by 2. So that's going to be 2 plus 1j. But now, what happens? Let's have a look at this example here. E. How many minutes we got left there? Almost, okay. Let's do this one. So let's take this here. Z2 divided by Z1. Okay. So what is my Z2 here? It's minus 3 plus 7j divided by, what is Z1? 4 minus 2j. Okay, now we got a problem here, because if I just had like 4, then I could divide it like how we always divide. Can you see that? The problem is there are 2 terms here now. So I cannot split this up. So I have a complex number as my numerator, and I have a complex number in my denominator. In order for me to divide, I do not want a complex number in the denominator. I want a real number, so I can just divide it. Can you see that? So, what is the technique that I can use to convert a complex number to a real number? And here comes the concept of conjugate. Remember, there's a complex number multiplied by the conjugate, and when I multiply the complex number by the conjugate, what appears? A real number, and then I can divide. So that's exactly what I need to do here. I need to turn this 4 minus 2j into a real number, and how do I do that? By multiplying 4 minus 2j by the conjugate, which is going to be 4 plus 2j. Now remember, I cannot just write down 4 plus 2j in the denominator. Whatever I do in the denominator, I must do in the numerator. 4 plus 2j. Effectively, I am multiplying this fraction by 1. Can you see that this is 1? Anything divided by itself is 1. So now, what will I do? Multiply out the numerator, multiply out the denominator. Let's see what happens. So I've got minus 3 times 4, which is minus 12. Minus 3 times 2j is minus 6j. 7j times 4 is 28j. And 7j times 2j is plus 14j squared, all divided by. Now notice, when you multiply a complex number by its conjugate, basically a plus or a plus bj is being multiplied by a minus bj, which is the difference of two squares. Okay, this is the difference of two squares. So it's going to be a squared minus b times j squared. The middle term will always cancel in the difference of two squares. Can you see that? That's why it's unnecessary to go and do it the long way. So in a case like this is going to be 4 squared minus 2j squared one time instead of doing it the long way, because it is the difference of two squares. So now we got minus 12, 28j minus 6j will be a positive 22j, and then we got plus 14 times my j squared there. Here 4 squared is 16 minus 4j squared. Okay, what is j squared? J squared is minus 1. So now, let's see what happens here. I have minus 12 plus 22j. Positive times negative will be a negative 14. In the denominator, I have 16 minus 4 times my j squared. What is my j squared? Minus 1. So now, let's do this here. In my numerator, what do I have? Minus 12 minus 14. So what is minus 12 minus 14? That will be minus 26 plus 22j divided by, in my denominator, 16, negative and negative will give me positive, so 16 plus 4 is 20, and finally now, what happened here? I have a real number. So when I have a real number, all I have to do is divide minus 26 over 20 plus 22 over 20. J, divide this here for me quickly. Minus 26 over 20 is equal to what? Minus 1,3. 22 over 20 is equal to? Positive 1,1. J, and that is your answer. Now, if you got this calculator here, let me this calculator. If you have this calculator here can work out. It can do the division, so let's do it. So if I go to mode and I go to number 2, which is complex, here's number 2 there, and now I can type this out. So what am I dividing here? Minus 3 plus 7j, so let me type that out. So this is minus, okay, let me put my fraction button there because I'm dividing. Minus 3 plus 7. In order to get j, it's the ENG button. You just press ENG there. Minus 3 plus 7i divided by 4 minus 2i. So the calculator is using the symbol I, we're using the symbol j. And then you press equals to, and it gives you minus 13 over 10 plus 11 over 10. 13 over 10 is 1,3. And 11 over 10 is 1,1. So the calculator in just 2 seconds gives you the final answer. If you do not have this calculator, you can download it on Google Play Store. Right, so that will be all for now. And then we continue next time. We need to finish this section.